So now that you know how to identify a significant figure, it's important that we move on to the even more important topic of how do we use significant figures in calculations. So when we're doing calculations, and we do those a lot in science, we are going to need to know how to present that mathematical answer. Now we know that when we were recording a measurement that all numbers that are written down with purpose. They're communicating a certain level of accuracy, a certain level of precision, I should say, in the instrument that we're using. And we want to make sure that our final answer is no more precise than our least precise measurement. So we want to kind of limit the number of significant figures that end up in our final answer. Unfortunately, the answer is not quite as simple as what you might hear in a math class. Most of the times, your math teacher might tell you to round your final answer to a certain number of digits, like give me two decimal places past the decimal point, or 3 places past the decimal point, or round to a whole number. And unfortunately, it's just not that cut and dry in science classes. Now, what you're about to learn hopefully will make it more cut and dry because we do have a system of rules in place. So here we go. Let's learn how to apply significant figures to everyday calculations. Now, when you are going to do some math, we know that there are essentially 4 basic operators. You can add and subtract, you can multiply, you can divide. And what I see these in is as in 2 groups of essentially opposites. So addition and subtraction are essentially the same idea, but opposite to each other. The same way that multiplication and division are the same idea, just opposite to each other. So knowing this, scientists developed one rule for addition and subtraction together, and one rule that applies to multiplication and division. Let's take a look at the addition and subtraction rule first. So for addition and subtraction, we need a sample problem. So here is one. Let's pretend that these are lengths that we would have measured. So one length was 12.155. Now that must have been measured with a really precise ruler because look at how far down our decimal places go. That last 5 is our estimated digit, which means on the scale, it should have been able to measure down to the hundredths place. That's small. And then the second measurement, 1.1, it's only recorded to the tenths place. That would imply that that tenth, that 0.1, is the estimated digit, which means that this ruler must have only had the ones scale present. We don't want our answer to be any more precise than our worst measurement. So even though in the calculator you might come up with the final answer of 11.055, we cannot report all of that information. It's just not conveying that perfect level of accuracy, that perfect level of precision that you really want. So that's no good. So let's take a look at both of our measurements again. Obviously, that 12.155 is way more precise. It was measured with a lot more care. Whereas this 1.1 has way much lower precision. It was not measured with as much care or with a correct or better instrument. We really can't have our answer being any more precise than our worst measurement, and that's that 1.1. So we're going to have to round our answer to that last common place. So since both numbers have the tenths in common, we can round our final answer to that place as well. So instead of saying that this measurement would be 11.055, we would in fact round it to 11.1. So here the addition subtraction rule has told us what decimal place up to that I can keep. In this case, we can only keep up to the least significant digit. So because 1.1 ended in the tenths, our answer has to end in the tenths. Let's take a look at the second rule for multiplication and division. Now let's use the same numbers, but let's change the operator. Now the math here is a little bit different. Remember the long style of multiplication or the long style of division, you would first start with that 0.1 and you'd multiply it by the 5, now this 5, now this 1, now the 2, and now the other 1 to try and present your answer, and then you're going to add that to the next round of doing that. Now, the problem with that is that your error in measuring that 0.1, that estimated digit, has now spread into every other digit. So it's poisoning your whole measurement. That's really not good. So we need to separately consider the sig figs in each one of these measurements. 12.155 contains 5 significant digits, whereas 1.1 only contains 2 significant digits. Now, what's really neat about the multiplication and division is, again, although we might in our calculator get the final answer of 13.3705, we want to make sure that our answer is no more precise than our worst measurement. So 1.1, because it has 2 significant digits, I'm now going to round my answer to 2 significant digits. So we're going to get rid of that whole decimal section and round that to just plain 13. So if I could summarize, I would definitely say that addition, subtraction, you want to make sure that you're rounding to the last common decimal place, but multiplication and division uses the least number of significant digits, total significant digits. So again, addition, subtraction, it's to the last common decimal place. Both numbers have to have that decimal place in order to be rounding up to that. Whereas multiplication and division, you just count up the total number of sig figs and you apply the least. So time for a little bit of practice, and I'm hoping that this will be helpful to you. Here are some sample problems for you to try. I'm going to ask you to pause the video, try them to the best of your ability, and in just a moment, I will unpause it for you and reveal to you the answers. Well, welcome back, and here we go. The answers to these problems. So problem number 1, we have subtraction. The last common decimal place between these two numbers is the tenths place. So no matter what you get in your calculator, you round it to the tenths, which is why you get 45.2. Number 2, we're dealing with multiplication. So here you're going to count the total number of sig figs. 24 has 2 sig figs in it. 2.987 has 4 sig figs in it. Our answer can only have 2 total significant digits, hence the answer 72. Problem number 3, we're back to addition again. It doesn't matter that there's 3 numbers, it's all addition, so it's the same rule. We're looking for the last common decimal place. Well, the worst number in here is just plain 3. It only has 1 significant digit, it's in the ones place, so all numbers have that ones place. I have to round my final answer up to that ones place, which is why you see it appearing here as just plain 33. Finally, problem number 4, we're back to division. We have to look at the total number of significant digits. 45.2 has 3 sig figs. 3.1423 has 5 sig figs. Well, we have to take the fewest, that's 3 sig figs, and that gives us a final answer of 14.4. One last topic before we are completely done talking about significant figures and calculations. That would be a problem like this. What if I have combined mathematical operations? So here we have addition and we also have division. Those are 2 different significant figures rules. So what do? Well, we do 2 different math problems and we round for significant figures according to each rule. You cannot put these style of problems directly all into the calculator at the same time and think it's going to be okay at the end. You must round in between. So we're going to go through the addition part first because it's in the parentheses, and then we're going to have to round for significant figures. So I get in the calculator 2.748 plus 1.7 comes out to be 4.448. And again, the addition rule says I have to keep that last common decimal place. That would be to the tenths. So I'm going to round this number to 4.4. That's the answer I'm now going to carry into the second part of the problem in the division part. So now I'm going to take 4.4 and divide it by 3.678. Now, the division rule is about the total number of sig figs. 4.4 has 2 significant digits, and 3.678 has 4 significant digits. So I'm only going to be able to keep 2 sig figs. So instead of the answer in the calculator, which is 1.1963023, too many digits, we need to round it to 2. So I'm going to get rid of all of that junk at the end and round accordingly. In this case, because that last number is a 9, I have to round it up. So my final answer is going to be presented as 1.2. It's going to take a little getting used to, but once you are actually able to be fluent with these two rules, significant figures can become the most natural thing in the world. It's nice to have a system of rules in place to tell you how many digits you can actually leave behind after every single mathematical calculation. I hope you found this helpful, but if you still need some help, remember I'm always here for you.